Right now, beneath your feet, the concrete walkway leading to your front door is actually physically breathing,
Yeah, it really is.
which is wild because it doesn't look like it, right?
Yeah.
Step out of our cars,
Right.
look at that path, and we just assume it's, solid, static rock, like the ultimate unchanging background element of our built environment.
Right. Totally static.
Exactly. But that surface is actually expanding, contracting, and basically fighting this microscopic 24-hour-a-day war against the earth below it and the sky above
It
it.
is a phenomenal feat of structural resilience that we honestly just completely take for granted.
Yeah.
I mean, we treat concrete as this absolute constant, like you pour it, it hardens, and end of story. But in reality, an exterior walkway is it's a highly engineered bridge sitting on top of a really volatile, shifting landscape.
Which brings us to today's deep dive.
Yep.
We are exploring the hidden engineering, the complex chemistry, and the surprisingly, I guess, elevated artistry required to build something you step on every single day without a second thought.
It's a lot more complex than people realize.
Yeah. Oh, absolutely. And our source material for this exploration is an expert guide from Palmetto Concrete. They're a trusted, specialized service operating out of Palmetto, Florida.
And looking at Palmetto and Manatee County on the Florida Gulf Coast, well, it gives us the perfect stress test for this material.
Right, because of the weather.
Exactly. If you want to understand how a paved path survives, you really have to look at one of the most demanding exterior environments you could possibly build in.
Okay, let's unpack this. Because our mission today is to reveal how laying a seemingly simple path is actually a high-stakes battle against nature. So I want you to picture your own front walkway.
The one you walk on every day.
Yeah, exactly. It's the literal path to your home. It dictates the entire first impression of your property.
Right.
But the structural integrity, keeping that path from, crumbling into a tripping hazard,
Yeah.
is entirely dependent on the specific climate it sits in
Right.
and the Florida environment.
Yeah.
It aggressively does not want that walkway to exist.
No, it doesn't. It is essentially a perfect storm of material degradation. Well, in Manatee County, you are dealing with intense, just unrelenting ultraviolet sun exposure from above.
Which breaks things down.
Yeah, it breaks down chemical bonds over time.
Yeah.
And then you have heavy, battering seasonal rains. And beneath the surface, the region has notoriously high water tables.
Oh, wow.
Add to that, the foundation itself is this shifting, unstable, sandy soil.
So the concrete is getting cooked by UV radiation, it's pounded by torrential water, and underneath, it's essentially like floating on a wet sponge.
That is a very accurate way to put it, yeah.
It's no wonder that throwing down a walkway isn't just a casual weekend project.
Yeah.
And yet, you see people at the hardware store loading bags of dry mix into their trunks, assuming it's just a matter of adding water and, smoothing it out with a trowel.
If we connect this to the bigger picture, you start to see why those weekend DIY projects in a climate like this turn into absolute disasters.
Right.
Because pouring concrete isn't drying, it's a chemical reaction.
Wait, so it doesn't dry?
Not at all. And amateur pourers in Florida frequently end up with slabs that sink aggressively into the ground, or they develop these massive jagged fractures across the surface.
Jeez.
Yeah, and ultimately they create dangerous water pooling right against the home's foundation.
I think a lot of people just totally misunderstand the chemistry there. They treat concrete like mud that just needs to bake in the sun.
Which is exactly what you don't want.
Right. But as you said, it's an exothermic chemical reaction called hydration. So the water and the cement compounds react to form a crystalline matrix.
What exactly?
Which means the water-to-cement ratio isn't a casual suggestion. It dictates the structural density of that entire matrix. It's kind of like baking a cake, right?
That's a good comparison.
Yeah, if you mess up the wet-to-dry ingredient ratio in baking, the cake totally collapses. And I imagine trying to get that precise ratio correct while standing outside in sweltering 90% humidity completely alters the moisture dynamics of the mix.
It alters it completely. The ambient humidity in Florida is actively interfering with the water volume in your batch.
Wow.
So if you add too much water trying to make it, easier to smooth out, you end up spreading those microscopic crystals too far apart during the hydration process.
Which means it's weak.
Yes. You end up with a structurally compromised matrix. A single miscalculation in the mix doesn't just give you an ugly finish. It fundamentally weakens the internal bonds holding the whole slab together.
So what does this all mean for the homeowner who thinks they could just save a buck with a few bags of hardware store cement?
Well, the DIR thinks they saved $1,000, but they've actually just poured a brittle, porous sponge, and it's doomed the second the heavy seasonal rains hit.
Because it just absorbs the water and cracks.
Right. Which means professional, local knowledge is essential. Understanding exactly how today's humidity and temperature will affect the cure is the only way to guarantee a surface that survives for decades.
That makes a lot of sense. But even with the perfect chemical mix, reading through this Palmetto Concrete guide, I was struck by how much of the survival of a walkway is determined before the wet concrete ever even arrives.
Oh, absolutely. The longevity of exterior concrete is entirely dictated by the ground game.
The ground game.
Yeah. In an environment with loose, sandy soil that shifts and holds water, preparing the site is a rigorous, non-negotiable science.
Walk us through that excavation phase, because it's not just like digging a trench to pour rock into, is it? The guide explicitly details the meticulous removal of all organic matter.
Yes, every root, every weed, and all the topsoil.
Every single root.
Every single one. It's a crucial step that amateurs always skip. You have to get down to a stable inorganic layer.
Yeah.
Because if you leave organic topsoil or root systems underneath the pore area, that material is going to decompose over time.
And when organic matter decomposes, it off-gasses. It literally vanishes, leaving actual pockets of empty air, like voids, beneath a rigid slab of concrete that weighs thousands of pounds.
Precisely. And when a heavy delivery truck drives over the walkway, or even just the sustained weight of the concrete itself presses down on that empty void, the slab fails.
It just snaps.
It cracks straight through. So once they remove that organic risk, professionals build an entirely new structural foundation, utilizing a subbase of crushed stone or gravel.
And they don't just dump the stone, right? They compact it heavily with machinery.
Yes, with heavy compactors.
From an engineering standpoint, this acts like a dense, load-distributing platform, but it also functions almost like a French drain, right?
That is the vital secondary function. With Florida's high water tables and aggressive rains, you cannot have water sitting directly against the bottom of your concrete slab.
Because it'll just erode the base.
Right. That highly compacted crushed stone promotes essential water drainage. It pulls moisture away from the concrete while providing this unyielding base.
Then the crew maps out the exact dimensions, the curves, the angles. They lock in a steel or fiberglass reinforcement grid to give the concrete the internal tensile strength it lacks on its own.
Which is critical for a rigid material.
And then the wet pour actually begins, which sounds like an incredibly stressful race against the climate.
It really is. The active pour is highly time-sensitive. The crew has to level, float, and finish the surface rapidly.
Because of the sun.
Yeah, the relentless Gulf Coast heat will accelerate the hydration process. It causes the concrete to flash cure or set prematurely before they can achieve the required structural finish.
Okay, here's where it gets really interesting. Because the crew does all this backbreaking work, right? They engineer the drainage, they race the scorching heat to get a flawless, perfectly smooth surface.
Right.
And then right before they finish, they take their tools and intentionally slice deep grooves right into the brand new walkway. I mean, why on earth would you slice grooves into a perfectly smooth brand new path? To anyone watching, it looks like you're vandalizing your own masterpiece.
It is an incredibly counterintuitive sight, but those cuts, which are called control joints, are basically applied material science. The reality is that all concrete has the physical potential to crack. You cannot stop it.
Because of the thermal expansion.
Exactly.
Even if it looks static, that slab is swelling in the midday sun and contracting at midnight.
Right. The concrete physically grows and shrinks as the temperature fluctuates. And despite the perfectly compacted crushed stone beneath it, there are always going to be microscopic shifts in the earth.
Which pulls on the concrete.
It introduces immense tensile stress into a rigid material. So instead of hoping the slab doesn't fracture under that stress, contractors cut those hidden grooves to dictate the failure point.
It's brilliant in its pragmatism. You are accepting the forces of nature rather than fighting them with pure brute strength.
Exactly. You relieve the stress exactly where you want it relieved.
You are essentially giving the concrete permission to crack, but forcing it to do so cleanly at the bottom of a hidden groove, so you don't get a jagged, aggressive fracture creeping across the visible surface of the path.
It's a controlled sacrifice that saves the aesthetic and structural integrity of the entire installation.
Which brings us perfectly to aesthetics. Because now we have an indestructible, scientifically grooved, heavily reinforced slab. But let's be honest, standard gray utility concrete can look a bit brutalist.
Can be a little uninspiring,
Yeah,
yes.
and the Palmetto Guide spends a lot of time on modern architectural finishing techniques that elevate this material far beyond, just the standard sidewalk.
Modern exterior hardscaping has completely revolutionized what concrete can look like. Contractors can utilize pouring and finishing techniques to seamlessly replicate high-end, expensive architectural materials.
And at a fraction of the cost.
Exactly, at a fraction of the cost without sacrificing that structural engineering we just discussed.
So the guide details 3 main modern finishes. Let's look at the first one, stamped concrete.
Right.
I know the basic concept here is pressing large, intricate textural mats into the surface while the concrete is still wet, stamping it to mimic natural stone, classic brick, or even like rustic wood planks.
That's the process.
But I've seen stamped concrete at older resorts or pool decks where it chips, and suddenly underneath the fake terracotta texture, you just see bright white or gray utility cement.
Yeah, that happens with older methods.
It shatters the illusion instantly. How is modern stamped concrete avoiding that cheap look?
What's fascinating here is the evolution of how color is applied, which ties into the third technique the guide highlights, colored concrete.
Oh, okay.
Historically, contractors might have just used a surface dye or a stain on top of a gray slab, so when that surface chips, the gray shows through.
Right.
But a premium installation today uses what are called integral pigments.
Meaning the pigment is mixed directly into the batch truck before the pour even happens.
Yes, the color goes all the way through the entire volume of the concrete.
Oh, it's like a chocolate cake. Because the integral pigments are mixed directly into the batch, the color goes all the way through the batter, rather than just being like painted on top like frosting.
That's a great analogy. It becomes a monolithic, cohesive material. If you drop a heavy tool on a deeply colored, stamped concrete slab and chip it, the material underneath is the exact same color.
Wow. So it maintains the illusion completely.
Completely, allowing you to match existing roofing, exterior paint schemes, or specific landscape designs permanently.
That makes a huge difference.
Yep.
Now, the second finish mentioned is exposed aggregate. I imagine this is particularly relevant for the climate we are discussing.
It really is. Exposed aggregate is achieved by removing the very top layer of the cement paste right after the pour.
Okay.
This reveals the natural stones, quartz, and pebbles that are mixed inherently into the concrete. Visually, it provides a very rugged, organic aesthetic, but practically, it creates a highly textured surface.
Which is an immediate safety feature. Like if you have those heavy, sudden Florida seasonal rains, you do not want a slick, glossy surface when you're trying to carry groceries to the front door.
Definitely not.
Exposed aggregate gives you that necessary slip resistance. But let me push back a bit on the long-term viability of the other finishes.
Okay, go ahead.
These finishes sound beautiful, whether you have a classic historic home near the Manatee River or a sleek modern build. But does making it look fancy compromise its durability? Like stamping a walkway to look exactly like rustic wood planks sounds gorgeous. But at a certain point, why not just use the real materials?
You aren't compromising the durability at all. In fact, you're actually vastly expanding it while reducing your maintenance burden.
Oh, really? Less maintenance than real wood or stone.
Consider the reality of authentic materials in a subtropical climate. Real wood planks warp, they splinter, and they require constant, highly toxic sealing against rot and termite damage.
Oh, that's true. Termites are awful there.
And real brick pathways. They settle unevenly over time, creating tripping hazards. Not to mention, weeds relentlessly grow up through every individual mortar joint.
Right. And natural stone is incredibly expensive to source, it's heavy to transport, and it's super difficult to keep perfectly level on shifting sandy soils.
Exactly. So a stamped, integrally colored concrete slab gives you the exact same visual warmth and architectural impact of wood or stone, but it remains a single, continuous, structurally reinforced unit.
Because weeds cannot grow through a solid slab.
Right. It doesn't rot. It is a premium aesthetic solution with a fraction of the ongoing maintenance.
Okay, so the engineering is rock solid. The aesthetics are deeply customizable and cohesive. Let's talk logistics.
Sure.
Timelines, upkeep, and the long-term ROI. Because if you're pulling up your front path, you need to know exactly how long your front yard is going to be a heavy construction zone.
Well, given the amount of heavy engineering involved, the excavation, the soil removal, the crushed stone compaction, the timeline is surprisingly efficient.
How efficient are we talking?
For a standard residential walkway in Palmetto, you are looking at 2 to 4 days of active work.
Wow, that covers the ground game, the framing, the pour, and the finish.
Yes. Now, if you are requesting highly complex stamping patterns or specialized integral coloring combinations, you should expect to add an extra day to that schedule for the meticulous finish work.
That makes sense.
And crucially, once the crew leaves, you must wait a minimum of 24 to 48 hours for initial curing before anyone can actually walk on that new surface.
Right, because that hydration chemical reaction we talked about needs undisturbed time to build its crystalline strength.
Exactly.
But what about maintaining it after those 2 days? If you've invested in a beautifully stamped, integrally colored concrete path that perfectly matches your modern build, how do you prevent the environment from degrading it 5 years down the road?
The day-to-day upkeep is incredibly straightforward. You just sweep it or gently hose it down.
Okay, that's easy.
But for stamped and colored concrete specifically, you must apply a high-quality UV-resistant concrete sealer every 2 to 3 years.
Ah, because the intense Gulf Coast ultraviolet radiation will eventually break down the pigment bonds.
Exactly. The sealer acts as a sacrificial protective shield. It stops the sun from fading your custom colors, and equally importantly, it creates a vital barrier against organic stains.
What kind of stains?
Well, in a damp environment, wet organic material like fallen leaves just sitting on the path will leach dark tannins that can deeply stain unprotected porous concrete.
Oh, I've seen that. Those brown, leafy outlines on the sidewalk.
Yes, the sealer prevents tannin stains as well as stopping any leaking vehicle fluids from penetrating the surface.
Hose it off, seal it every few years, when that is vastly easier than releveling sunken cobblestones or replacing rotted wood.
It really is.
Which brings us to the financial reality. Upgrading a walkway clearly improves the daily usability of a home, but does the data support the upfront investment?
This raises an important question regarding property value. According to the source data, upgrading the front entry remains one of the highest return on investment improvements a homeowner can make in Florida.
Really?
Yes, it immediately resolves dangerous, uneven pathway hazards while drastically boosting curb appeal.
I mean, it sets the standard for the entire property before someone even rings the doorbell.
And the experts at Palmetto Concrete point out a highly effective strategy for maximizing that monetary value: architectural flow.
Architectural flow. Tell me more about that.
Well, the most striking properties don't just have a beautiful front walkway that abruptly ends at a messy side yard. They connect that elevated design straight through, seamlessly transitioning the front yard walkway into the backyard patio concrete slabs.
Oh, that makes perfect sense.
Yeah.
You use the exact same stamped pattern and integral color to create a unified architectural language around the entire perimeter of the house.
Exactly. It turns a fragmented yard into a cohesive, deliberate landscape.
It makes the usable footprint of the home feel significantly larger, too.
It creates an estate-like feel, drastically enhancing both the daily usability and the ultimate resale value of the property.
So bringing all of this together, what we've discovered today is that a simple path to your front door is anything but simple.
It really isn't.
It is a masterclass in local climate science.
Mm.
You know, understanding exactly how humidity alters chemical hydration. It's a marvel of hidden structural engineering, relying on precise excavation, compacted drainage subbases, and strategically cut control joints to manage the thermal expansion of a breathing material.
And perhaps most surprisingly, it is a canvas for elevated artistry.
Right, using integral pigments and complex stamping to basically replicate nature itself.
It requires immense precision, deep local expertise, and an understanding of soil mechanics to make something so complex look perfectly static and permanent.
So to you listening, the next time you walk up to a house, take a moment and just look down. I promise you, you will never view a simple concrete walkway the exact same way again, knowing the sheer scale of the engineering and the hidden battle against nature happening right under your shoes every single day.
The most impressive structural achievements are usually the ones designed to go completely unnoticed.
Absolutely. And before we end today's deep dive, I want to leave you with a philosophical thought to mull over based on what we've learned. We discuss how modern concrete finishes, using integral pigments and precise textural stamping, can brilliantly replicate expensive natural materials like rustic wood planks or classic stone.
Right.
And we learned that this properly engineered, reinforced concrete is actually more durable, incredibly resilient to harsh environments, and requires significantly less maintenance than the real wood or stone it is copying.
That's true.
So my question for you is this. If modern engineering is getting so incredibly good at mimicking nature visually while completely outperforming it functionally, At what point does the fake replica actually become a superior, more desirable material than the original nature it was meant to imitate?
Wow, a fascinating paradox to consider.
Thank you for joining us as we uncover the complex world beneath our feet. Keep questioning the everyday things around you, and we will catch you on the next deep dive.